Hi students, our study today is about logarithmic function. Logarithmic function, we're going to start by the number e, which is 2.718, etc. This is an irrational number. This number is very important in mathematics. It's like a golden number. It's used in finance. It's exponential growth decay. It is used in banking. It is used to know the age of a rock, the age of any specific material. So this number is important, and it's called Euler number. So we're going to graph this Euler number y equal ex. In calculator, if you want to get the number e, you do shift len. You have in calculator logarithm, you do shift len. So if you do shift len, ln, under you have len and log. If you do shift len, you're going to get e power. So if you put e power 1, you're going to get a number 2.71828, etc. This is an irrational number. So as I said, this is a golden number. So if you want to graph this number e, so here e is positive. So if you want to graph, you can take x to be 0, e power 0, 1. If x is 1, 2.72, minus 1, 0.37, etc. As you can see, always y is always positive. Why? Because e is positive. E raised to any power, it's always positive. So it is this is here, you can see here as x tends, because 2.718, if you do the limit as x tends to minus infinity, this will be 0. So here y will be 0, y equal to 0 horizontal asymptote. So if you graph it, this is the exponential. Since this function is strictly increasing, it admits an inverse function with respect to y equal to x. This inverse function is called logarithm, len x. Okay, so this is y equal len x. So what is len x? Logarithm, this is named Neperian logarithm. And for Neperian, the mathematician who discovered the inverse of it, Neperian, his family name John Neper, his name is John Neper. So Neperian logarithm. So if you have y equal e power x, its inverse is y equal len x. Now we have here y equal e power x. As I said, x can be anything, positive or negative or 0, but y is always positive. Now the inverse of exponential is logarithm. So how do you find the to find the inverse? So to find the inverse, we start by the power of e, which is x here. The inverse of e is len. E Euler, he's a mathematician. Len Neperian John Neper, len of y. Okay, y is always inside, is always positive. You cannot have len of negative. So if you put in calculator, len of negative is impossible. So here it is always positive, and x is can be anything. So that's why x equal len y. X belong to R here, can be anything, but inside is always positive. So this is concerning logarithm. In the second slide here, we can see that this is a finance, banking finance. It's a compound interest. So if you want to take the interest here, as you can see, as long as the time here you slower the time of the interest, so you're going to get the number e 2.718 to 82. So this is another example, the importance of the exponential, where it is used in compound interest formula in finance. So as I said, if you have y equal e power x, this is exponential, x equal len y. Always in logarithm and vice versa, if x equal len y, y equal inverse of len is e power answer, e power x. And always in logarithm, if you have y equal len x, this is always positive, x is always bigger than 0, and y belong to R. Before I start by some application, now we know that e power 0 is 1. So if you want to find the inverse, so you start by the power. 0 is len 1. So that's why len 1 is always 0. We know that e power 1 is e. So this implies if you start by the power to find the inverse, 1 equal inverse of this e is ln of the answer. The answer is e. So ln e is 1. Ln e is 1. Ln 1 is 0. I will be satisfied for the time being by these two only. Later on we're going to take more. So if you want to solve for x, so here you can see that the power of x is above the exponential. So we need to introduce ln to find it. So first of all, you take the 4 to the other side. 10 over 2 is 5. So x minus 2 equal inverse of e is ln of the answer 5, and x will be 2 plus ln 5. If you want to write it in decimal, you can use your calculator. So here you take this to the other side. Minus 25 over minus 5 is 5. So 2x minus 1 equal ln 5, and x will be 1 plus ln 5 over 2. Here, if you take this number to the other side, you know that exponential, as we said, can never be negative, so impossible to solve. Exponential equal negative, impossible. Here, you take the minus 7 to the other side, 15, so 5 over 15 over 3 is 5. So minus 2x plus 1 equal ln 5, and x, this is the answer. Here, let us do solving with respect to logarithm. 3 to the other side is 10. 10 over 2 is 5. So we start from inside. So x minus 2, inverse of ln is e power 5, and x will be 150.41. Don't forget that this always must be positive. So if you're going to replace 150.41 minus 2, it is positive. Here, more example. Minus 3. So we take the minus 10 to the other side, over minus 3 is minus 4. Logarithm can be negative answer, but inside must be positive. In exponential, for example, equal to y, here must be positive. This y must be positive, and the power can be anything. In logarithm, the answer can be positive or negative, it doesn't matter. But however, inside must be always positive. So minus 2x plus 1, inverse of ln is e power minus 4, and you solve it. If you replace here inside, it's 100% it's true. So here minus 8 to the other side, over 2 you have this one. So x squared minus 1 equal e power 2. So x squared equal e squared plus 1. If you replace these two values inside, it is also positive. So here you take it to the other side, it's 0. So ln x equal to 0. So x equal e power 0, 1. I told you, ln 1 is always 0, and ln e is 1. So this is an equation of second degree in ln. You can say ln square x, by the way, ln x square, it means you have ln x times ln x inside. There is a property for it. We're going to take it later on. However, if you have ln x times ln x, this is ln x all square. Not to write it with parentheses, you put the power above n. Ln square x. So this is an equation of second degree. A is 2, B is 5, C is minus 3. If you use your calculator directly without doing delta, you have two roots, minus 3 and minus 3 over 2. So x equal e power minus 3, or x equal e power minus 3 over 2. Now, as we said, if you have y equal ln x, x is positive and y can be anything. Find the domain. Certainly here x minus 2 bigger than 0, x bigger than 2, minus 3x plus 9 bigger than 0, x less than 3. X squared plus 5 is always positive, so domain is everything. X squared is positive but cannot be 0, so x belongs to everything except 0. Here this is positive, so down must be positive. Here this is a second degree equation, so this must be bigger than 0. You have two roots, minus 5 and 1, same sign, opposite sign, same sign as A. So plus minus plus, so to be positive, either it's here or here. So this is the first video about property of logarithm and its relation with exponential. Thank you for listening. Now we're going to start by video number 2.